Hello students, I am Gurmeet Singh. Welcome to CREATA classes and also welcome to the coordinate geometry series for class 10 student. In this lecture, we will cover the exercise 7.1 question number 1 to question number 5. We use the power of visualization, that is visual tools and techniques to understand the concept in much easier way. Do not forget to download the PDF of the concept and the formula list. The link is given in the description. So without taking any further time, let's start the question number 1 of exercise 7.1. Here it is. The first question is, find the distance between the following pair of points. 3 subparts are given, we will take one by one. Let's take the first part. We have to find the distance between the two coordinate, that is 2, 3 and 4, 1. Here if we take x1, y1 as 2, 3 and x2, y2 as 4, 1, we can directly apply our distance formula, that is root of x2 minus x1 whole square plus y2 minus y1 whole square. Simply we have to just put the value. On putting the value, we got answer of our first question as 2 root 2. Got it? Let's jump to the second question. In this question, we have to find the distance between the coordinate minus 5, 7 and minus 1, 3. Here x1, y1 is minus 5, 7 and x2, y2 is minus 1, 3. Directly putting the value, on solving we got our answer, that is the distance between these 2 points as 4 root 2. Okay, got it? Very simple one. Let's take the last part of this question, in which we have to find the distance between the 2 points. The first point is a comma b and the second point is minus a comma minus b. So let's proceed with this question. Let's use the distance formula to calculate the distance between both the points. So this is the distance formula. Let's assume the first point as x1, y1 and the second point as x2, y2. Let's put the value. Let's open the square term. We got this equation. Further solving, we got root of 4 and in the bracket a square plus b square. Let's take 4 out of the root. We got our answer as 2 root a square plus b square. Basically, simple question. All the three parts are very simple. Just we have applied the distance formula and we have got the result. Let's move to the question number 2. Find the distance between the point 0, 0 and 36, 15. Can you now find the distance between the two home A and B discussed in the section 7.2? So firstly, let's observe the question. Let's move to the section 7.2. In this section, a scenario is given in which we are having two towns, town A and town B. The distance or the direction of town B is given with respect to town A. That is, town B is at 36 km east of town A and 15 km north of town A. That is, the x and the y coordinate of town B is given. If we assume the town A at 0, 0 coordinate of the coordinate plane, that is town A is at 0, 0, this position, then we can calculate the coordinate of town B, that is 36 km east and 15 km north. That will be 36, 15. The x coordinate is 36 and the y coordinate is 15. Basically, we can use the Pythagoras theorem to solve this question. But in this question, which is the same question in the coordinate plane, we will use the distance formula to solve the question. If you observe the question, it is given we have to find the distance between the point 0, 0 and 36, 15, which is basically the distance between the town A and town B. So we have observed and visualized the question. Let's use the distance formula. Here, let's assume this point as x1, y1 and this point as x2, y2. Let's use the distance formula. Let's put the value. Let's open the square. We got root of 1521, which is basically 39. So we got our answer as 39. That is the distance between the 2 points. That is town A and town B. The second part of the question is saying, Can you find the distance between the two towns A and B discussed in section 7.2? So the answer is yes, we can do it. Got it? We have done with question number 2. Let's move to question number 3. Determine if the point 1, 5, 2, 3 and -2, -11 are collinear. Firstly, let's observe the question. In this question, we are having 3 points. 1, 5, 2, 3 and -2, -11. Let's name these 3 points as A, B and C. Further, the question is asking, are these points collinear? Means, are these points on a straight line? So how we approach the question in which we have to prove the 3 points are collinear or not? The same we have discussed in the theory questions also. But here, let's again understand that concept. If we are having 3 points A, B and C, if AB plus BC is equal to AC, then we can say the 3 points are collinear. If this distance AB and the distance BC is equal to the total distance AC, then the 3 points are collinear in a straight line. So we have got the fundamental that we will use. So let's approach the question. We have 3 points A, B and C. We will find the distance AB, BC and AC. Then we will equate AB plus BC is equal to AC or not. So let's find AB. We have 2 points x1, y1 and x2, y2. Let's use the formula. Let's put the value. Let's open the square term. On solving, we got the answer as root of 5. Got it? Let's move to BC. We will use again the distance formula. We know x1, y1 and x2, y2. Let's put the value into the formula. Let's open the square term. We got the answer as root of 212. Further, let's move to AC. Again the distance formula. We know x1, y1 and x2, y2. Let's put the value. On putting the value and solving, we got AC as root of 265. We got AB as root 5, BC as root 212 and AC as root of 265. So now let's check whether AB plus BC is equal to AC or not. By looking at the root term, we are not able to exactly find out whether these two terms are equal to AC or not. Let's try to open the roots. In the exam, the calculator will not be allowed. So let's try to use some of the trick. We know 14 square is equal to 196 and 15 square is equal to 225. So the 212 will come between 14 and 15. It is basically 14.56, but you can assume that it is 14.5. Similarly, AC is root of 265 and 16 square is 256. So root of 265 will be slightly higher than 16. That will be 16.27. Further, root 5 is 2.23. 2 square it is 4, so root 5 will be higher than 2. That is 2.23. So if you add AB plus BC, it will comes out to be 16.79, which is greater than AC. That is 16.27. So we can say AB plus BC is not equal to AC. That is, these 3 points are not collinear. Got it? These 3 points are not collinear. If you plot the 3 points on the coordinate plane, they will only form the triangle. These 3 points will not come on a straight line. So we have done with the question number 3. Let's move to next. The question number 4 is, check whether 5, -2, 6, 4 and 7, -2 are the vertices of an isosceles triangle. Firstly, let's observe the question. These type of questions are generally asked in the coordinate plane. 3 points are given or 4 points are given, and we have to find whether the 3 points will form the triangle or they will form the quadrilateral. If the triangle is forming, which type of triangle, and which type of quadrilateral, which type of parallelogram. So these type of questions are very common, and you should know all the types of triangle and the quadrilateral. In this question, we have to check whether the 3 points are forming an isosceles triangle. But the other question can be, that is, the triangle is an equilateral triangle in which all the three sides are equal, or an isosceles triangle in which two sides are equal, or an right angle triangle in which one angle is 90 degree. So all these different type of triangle you should know. In this question, 3 points are given and we have to check whether it is an isosceles triangle. If the two sides are equal, then we can easily check or prove that it is an isosceles triangle. We know 3 points, we know the distance formula, so we can easily calculate the distance or the sides of this triangle and we can check the same. Let's proceed and let's use the distance formula. Before that, let's give the name to these 3 points as A, B and C. We will find AB, BC and AC. So let's find AB. The coordinate of A is 5, -2 and the coordinate of B is 6, 4. We know x1, y1 and x2, y2. Let's use the distance formula to calculate the distance of AB. On putting the value and solving, we got AB as root of 37. Okay, we have directly applied the distance formula. We got one side of this triangle. Let's move further and try to find the side BC. Here these are the two coordinates. Let's assume B as x1, y1 and C as x2, y2. So we got x1, y1 as 6, 4 and x2, y2 as 7, -2. So we will use our distance formula. On putting the value and solving, we got BC, that is distance between these 2 points, as root of 37. Let's move further and we will try to find the distance AC. Here let's assume x1, y1 as 5, -2 and x2, y2 as 7, -2. Okay, we will use our distance formula. Let's put the value. On solving, we got AC as 2 unit. Got it? So we got the three sides of this triangle, that is AB as root of 37, BC as root of 37 and AC as 2 unit. Okay, the two sides, that is AB and BC, are equal to each other, that is this triangle is an isosceles triangle. Okay, got it? So with the help of the distance formula, we have proved this triangle ABC is an isosceles triangle. Got it? That is the answer of this question. Let's move to question number 5. In a classroom, 4 friends are seated at a point A, B, C and D as shown in the figure 7.8. Champa and Chameli walk into the class and after observing for a few minutes, Champa asks Chameli, "Don't you think ABCD is a square?" Chameli disagrees. Using distance formula, find which of them is correct. So let's observe the question. A classroom is given in which 4 points are given, that is A, B, C, D. These are the sitting arrangement of 4 students. 4 students are sitting on the point A, B, C and D. These 4 points are shown on the coordinate plane. So basically we can find the coordinate of all these 4 points. The coordinate of point A is 3, 4. The coordinate of point B is 6, 7. C it is 9, 4 and D it is 6, 1. If you want to know how we have calculated the coordinate x and y of all these 4 points, refer our first lecture of the coordinate geometry class. The link is in the description. Further, 4 points are given. Champa and Chameli, 2 students, enter the class and they observe the 4 points. And they are in the doubt whether these 4 points will form the square or not. If we join all the 4 points, what it will be? It will be a quadrilateral. Which type of quadrilateral? Whether it is an parallelogram, it is an rectangle, it is an square, rhombus, kite, trapezium, which type of quadrilateral it is. Before proceeding to this question, you should know all about the geometrical figure. We have specially covered about all the quadrilateral, all the parallelogram in very detail. Refer the link in the description for that video. But as a quick revision or a quick review, I will just guide you about the basic figures. This is the complete diagram of the quadrilateral. Especially the important are the parallelograms. Parallelograms in which opposite sides are parallel and equal. Parallelogram are basically of three types: rhombus, rectangle and square. We have a detailed video on different type of parallelogram. Check out the link in the description. Just a quick view: rhombus is a type of parallelogram in which all the sides are equal. Rectangle is a type of parallelogram in which opposite sides are equal and all the angle are 90 degree, that is equal, 90 90 90 90. Square is a type of parallelogram in which all the sides are equal as well as all the angles are equal. Rhombus, all the sides are equal. Rectangle, opposite sides are equal and all the angle are 90 degree. Square, all the angles are 90 degree and all the sides are equal. Further, regarding the diagonal, which is the important criteria to decide, in the rhombus the diagonals are perpendicular bisector. In rectangle the diagonals are equal. In square, diagonal are equal as well as perpendicular bisector. So you know about the different geometrical figure. Let's proceed with this question. In this question we will find the distance AB or the side AB, BC, CD, AD, AC and BD. Basically all the distance, that is all the sides and the diagonals we will find. Then we will see which type of quadrilateral it is. Let's start with AB. This is a distance formula and we know the point A and B, that is x1 y1 and x2 y2. Let's put the value. Let's solve it. Let's open the square. We got the answer as root of 18, which is 3 root 2. I am not explaining how to open this square and all those things, but you can pause the video and you can check the different steps. Let's move to BC. We know the 2 point x1 y1 and x2 y2. Let's use the distance formula. Let's put the value. Let's solve it. We got root of 18, that is again 3 root 2. Are you observing AB and BC both are equal to each other? So maybe we are going in the right direction. Let's move further to CD. Again distance formula, we know x1 y1 and x2 y2. Let's put the value, open the square. We got root of 18, that is 3 root 2. Again, are you observing? I think we are going in the right direction. All the three sides we got as 3 root 2, that is equal. Let's go to AD. Again the distance formula, all the points we know. We got the answer as root of 18, that is again 3 root 2. So we got all the four sides of the quadrilateral are equal. It means that it may be a rhombus or it may be a square, but it is not a rectangle. Further, how we will diagnose whether it is a rhombus or a square? We will go for the diagonals. If the diagonals are equal, then it is a square. If the diagonals are not equal, then it is a rhombus. Let's find the diagonal AC. Again, we know the 2 point. Let's use the distance formula. Let's put the value. Let's solve it. We got root of 36 as AC, which is 6. 6 square is 36. We got the first diagonal AC as 6. Let's move to BD, the second diagonal. We know both the point. Let's use the distance formula. Let's put the value and let's solve it. We got the answer as root of 36, which is 6. We got AC and BD, both the diagonals as 6, that is equal to each other. All the four sides are equal, both the diagonals are equal. It means it is a square. Right. It is not a rhombus, it is a square. It is a type of parallelogram which is a square. Don't be confused that parallelogram is a different than rhombus, rectangle or square. Parallelogram is the main entity which is further divided into rhombus, rectangle and square. Basically rhombus, rectangle and square are a type of parallelogram. Check the geometry video in the description. So students, we have done with the exercise 7.1 question 1 to 5. Hope you have enjoyed it. We use the visualization tools and techniques to make the concept easier for you. So that's it for this lecture. Thank you very much and have a great day. Bye for now.